Hello, Kanika, how are you?
Yeah, I am good. How are you?
Good, good. I have a question because
Yeah,
I know the 9 hours of BPC. Uh,
I have sent you the topics also, but if you want that, you don't want to learn the topics, these are the major topics that you need to cover for the exam. But if you already know them, you can just let me know that these topics you don't want to cover. We can just edit it, and the topics you want me to tell you, just specify that to me.
okay, yeah, I'm gonna reply to you after this session, and I just want to know because the for the BPC, I I I take courses about the BPC and a lot of practice. So I was thinking that we can focus on the theory part um, and and just leave the
Just give me a
practical.
second. Actually, I'm not able to hear you. Just
Oh,
yes.
yes, we can for the BPC because so we can do it in less time. We can leave the practical out because I haven't
So
like
you don't
much
want the practical part.
just the theory because I got the practical. I
Okay,
have
you
been
just
practicing in the
want
country.
the theoretical part. Let me check in how much time the theoretical part can be complete. Just give me a second. I'll tell you the timings also, like, so that it's very much clear for you, right, to choose the topics you want to learn.
Yep.
Hmm. Means in okay, practical, three practicals are included. So if we remove them, then yeah, time will be reduced. So it's fine. We'll do not include the practical part. We'll just cover all the theoretical parts so that it will be easy for you to complete the course as soon as possible. Okay.
Yes. Uh-huh.
And other topics, have you seen them?
Yes. So I'm going. Let me see. So very interested in taking the EBS. Just the storage because I just know like I wanna touch first the BPC and then the EBS.
See, actually, the complete storage, it needs to go in parallel. Like first we need to cover S3 bucket, then EFS, and then EBC will be worthful studying. Like, because if you understand S3 bucket very well, if you understand EFS, then understanding EBS role, because first S3 comes into play, then EFS comes, then EBS comes. So it will all be connected. Getting it?
I know the S3, but I
Okay.
don't know the that much about EFS. So um,
No, actually, I have just included EFS lab. Okay, no much theoretical part is there, because every theoretical part I have completed in a S3 bucket, right? So maybe
but I just kind of dominate the S3 bucket.
okay. So it's okay, fine. Then we'll not do S3 bucket and the related part. We will directly jump to EBS part. Okay.
Yeah.
Just let me just mark all these the things you don't want to do.
Can you touch just a little bit about EFS?
Yeah, I can show you the lab of EFS.
The theoretical part because I've been practicing of course the lab as well,
Yeah,
the EFS lab as well.
it depends, like in what depth you want to. Let's first do the EFS lab, and still you don't understand any concepts, we can see that theory also, right? That will be fine, because making you understand the storage, okay, that is very much complicated, but you already know SC bucket, so we can skip it.
Uh-huh.
Okay, we'll see. We'll first complete EBS, then we'll go with EFS. No issue.
Okay.
Okay, and
And how many hours?
like including okay, EBS, I'll tell you how many hours. Just a minute. 24 divided to 40. Okay. 4 hours EBS will take, means 2 days of classes EBS will take.
What about BPC?
BPC will take, just a minute. We have to remove the practical part. Let me check how much the practical part is taking. Then I'll tell you while calculating it. Peering concept. Okay, you don't want to go with the peering concept, right? PPC NAT, we have to go. We don't have to follow this. Okay. And you don't want VPC crossing between two regions also. Inside my VPC, lab and VPC connection. Endpoints. Yeah, it will take us 6 hours now. Okay.
For the BPC?
Yeah, it will take you 6 hours after excluding the 3 labs, that is peering with regions and creating the connection between two different regions lab and the complete lab of VPN. Okay, I have excluded VPN lab also, VPN connections. So excluding all them, they will take you 6 hours. EBS will take you 4 hours. Only theoretical part I'll teach you, but you don't want the EBC lab also, EBS lab also.
You can add the EBS lab, and
You need to include EBS lab.
no, let me see. Increment snapshot encrypted. Yeah, just include it. Um,
Then check another topics.
VPN connection.
Do you want VPN connection? Then I need to add that lab. It's a lab, VPN connection lab.
That will be important. How many hours is the lab? 2 hours?
Yeah, 40 divided by 60, just to give you 40 by 60 by 6, 2 by 3. Like it's half an hour, 40 minutes. It's 40 minutes. Okay.
Oh, okay, okay. Okay, we can include it.
Okay, so 40 minutes more you want? Let me just, yeah, okay. I'll try to complete in VPC and VPN in 6 hours. Okay.
Got it. Thank you.
Yeah. And you need EBS. Okay. Then you need the next topic is AMI for EC2. Okay. So it also contains the labs. If you already know, then we can exclude them also.
Yeah, I already know that. Just the theoretical part will be fine.
Okay. You only need a theoretical part, right?
Uh-huh.
Actually, these three are actually labs. So
Which one?
we can exclude all the three labs, no issue. Okay. AMI for EC2, all these are the labs. If you don't want them, we can just exclude them. Just let me. Okay, now. Then auto scaling. You want the theoretical part,
Yeah,
right?
just the theoretical part.
No lab you need in auto scaling.
No, no lab.
Okay, just a minute. Okay. If we exclude the lab, okay, fine. Then an elastic load balancer.
Just the theoretical part.
See, there will be three labs in this elastic load balancer. One is lab on AWS application load balancer, AWS network load balancer. Okay. So these two labs I need to exclude. Let me just take. Network load balancer and the last one. Okay, three labs I have excluded now. Okay, only theoretical part if we focus, we'll cover them. Then we have identity and access manager. Only theoretical part.
We can let me see. I am roles. You can explain I am roles, how to create a role. Um you just include the theoretical part, that's it.
Theoretical part, right?
Um,
Then AWS Route 53.
oh yeah, included the lab.
Okay. Yeah. And then CloudFront.
Yeah, including the lab. Uh-huh.
Okay. You want me to tell you the total hours it will take to complete the session? Whole-
Yes.
Okay, just give me a second. Then I need to calculate it. Removing things. It will take us 31 hours to complete the session.
All of them,
Okay, 31.
including.
And we have 9 lectures left. Okay.
That's including the PPC, right?
Yeah, everything, including everything. Let me just subtract 9 from that. Then we need only 21 hours more. Okay, because 9 hours we already have right now, right? And extra 30 will require, so only 22 hours we require more. 21.41 minutes means 22 hours we require. Okay, I'll write it here. Total 30 hours. I'll share you, okay, this time one also, in which I have calculated the time for each topic. Okay, so you can just monitor everything. Okay, just let me show you. Just check once. Just give me a second. I'll send you the Excel sheet, including the time. Just go through it and confirm that all these topics you need to understand. Okay, just check. I have sent you something else. Just give me a second. Okay, please check.
PPM, 6 hours, 4 hours. The AMI for EC2, how many hours can it take? 2 hours.
Just give me a second. Let me check.
2 hours. 90.
Which one you are asking? AMI?
AMI for EC2.
AMI for EC2. Actually, I've excluded it. But if you count them, it's 61 hour, 2 hours. It
Okay, I mean,
included.
let's leave it like that. Okay, so you exclude it's okay. Auto scaling. So in total it's 30 hours. And 30 hours, and we have 9 hours left.
Like we need extra, see, including, if we are including our 30 hours, means 30 hours it will take to complete all the topics. Okay, the topics that are written. Okay, and I have in front of each topic, I have written how much minutes it will take.
Okay, got it.
Okay, And we have already we have 9 hours, including today's hours. Okay, so we can if we exclude 9 hours, so we require next 22 hours more. Okay, to complete it.
Got it. It's not only 1 hour.
No, it's 22 hours. It's like 21 hours, 50 minutes. Like it's approximately 22 hours.
Okay. Okay. Yeah. Let's keep moving.
Okay, let's start with VPN, VPC now. Everything is confirmed, right? So see, once let's complete our 9 hours, right? Then we'll talk when to start with the next part, okay? And how we can move to it, okay? So I think that if we'll complete 6 hours of VPN, including, okay, VPN lab also, then EBS we require next 4 hours, means 10 hours will be required for EBS to complete, okay? So let's
Got it.
EBS and VPC, then we'll move to next part. Okay. So let me start with VPC. I'm fine, fine. Okay. So let's start with VPC.
Yep.
So VPC is known as Virtual Private Cloud. Okay. So what does this mean? So now we already have one cloud with us. Okay. We already have a cloud with us. Okay. Which cloud we are working on? That is AWS cloud. Okay. But this cloud is public. Everybody can access this cloud, right? Now, for what happens in a company, say this is Amazon company, okay? They say that we have a data, okay? And we don't want to give it to another company, say Facebook cloud, okay, to save this in their system. I don't secure, okay? So what they do, instead of getting into the public cloud, they say, I'll create my own private cloud. Inside this, I will put my data because this data is very much important. So it will be only accessible to my company. Nobody else in the outer world can see my data. Okay. So what they are creating a private cloud. Why they are creating the private cloud? For the security purpose. Okay. And because it is on internet and we can't touch it, that is why it's known as virtual. So that from that comes VPC. Now what AWS has done, AWS services come up with a solution to this problem. Okay, every company, means there are billions of companies, 1,000 billion companies say we have. Okay, Now, if each company will create their own cloud and storing their data inside it, so it will be very expensive for them, right? It will be very expensive for them to maintain, like the say Facebook says, I have 12 billion customers with me. Okay,
Okay.
just a second, just a second. It's okay. AWS services, what they have come with the solution. Okay, they say that if you are managing the data of 12 billion people, and if you will create your own private cloud and store that data inside it, it will be very expensive for you. And sometimes what happens, we don't sometimes unnecessary data also get us. So what we want, instead of this, what we can do, you come to us, AWS people say, you come to us, we will provide you a virtual private cloud. Okay, now every data that you want to be secure, you can easily keep in the virtual private cloud. So it will
Okay.
be secure and nobody else will be able to access your data.
Mm.
Getting it, this concept
Yep.
they're trying to say?
It's not through the. Uh,
Like
it's like
because
it's more
what
secure.
AWS saying, we are providing you at very much low cost. Why you want to create your own data center and it will be very expensive, right? So what you want, same, you want a cloud to store data for only 2 hours. But if you create your own cloud, you have to pay for 24 hours. So it will be very expensive. But if you want to store the same data for only 2 hours, you can take our virtual private cloud on rent for 2 hours and just pay for 2 hours. No need of paying for 24 hours. Getting this?
Yep.
This concept is clear? So now let's
Yes.
to the actual theoretical language, what they say about virtual private cloud. So a virtual private cloud is a virtual network that closely resembles a traditional networking that you operate in your own data center. This part is clear?
Yes.
With the benefits of using the scalable infrastructure of AWS. So once more, I'm just reading it for you that a VPS is a virtual network. First thing you need to understand. Okay, there is no physical network available that you can create or touch, but it's a virtual network and it closely resembles to the traditional networking that you do in your own centers. Okay, if you are creating some data, you want to keep that data somewhere and you want it to access with multiple peoples, okay, multiple departments. So you connect this department with a network to this department, you connect this department with this network, and so on, right? So you're creating a network own organization. Getting it? Similarly,
Yep.
you're doing the same thing using VPC with the benefits of using scalable infrastructure of AWS. Scalable infrastructure that you can use multiple services of AWS instead of creating in your own company. Okay, it provides you more benefits. Getting it?
Got it. Okay.
So now, if we move to just a second. So sorry, actually, it's a festival time, so everybody is in the house, and
Oh, okay.
just give me a second. Okay, let's continue. So this part is clear. Now the next thing, what or you can understand this in another way also. What you can say that VPC is a virtual network or you can say a data center inside AWS for one client. Okay, this is important that it is only for one client, means a complete network they are giving you only to you, just say client one. Okay, another client doesn't have any access to this data center. Getting it?
Yep.
Means what happens earlier in a single data center, multiple servers are running. Okay, see, this server belongs to Facebook, this server belongs to Microsoft, this server belongs to other company. But when you create a VPC network, they say we are assigning a complete data center only to your company and nobody else will be able to access the data without you or without your permission.
Got it.
Getting it?
Yep.
So what we can say that it is logically isolated from other virtual networks in the AWS cloud. Means it's completely isolated. No two networks. Say this is one VPC, this is second VPC. These two cannot be connected. They are completely isolated. This belongs to other company. Say what Facebook has done, they have created two VPCs. Say VPC 1 for some work and VPC 2 for second work. Because they are created by Facebook only, but still they don't able to connect with each other. This is how AWS so much strict with the VPC concept. Getting it?
Okay. So it's more secure.
Yeah, it's more. Maximum 5 VPC can be created
in one region.
and 200 subnets in one VPC. Okay, so these things needs to be remembered, that inside a complete region, if you talk, only 5 VPCs can be there and 200 subnets for a particular VPC. Okay.
Got it.
We can allocate maximum of 5 elastic IP. Okay, so only maximum of 5 elastic you can just imagine, not elastic, say IP addresses we have. Okay, generally IP addresses consist of 32 bits, right? So only 5 IP addresses you can access. Not more than 5 IP addresses you can access inside a VPC. IP address, you can say, is the address of a machine on which you are working. So right now, the computer you are working, how somebody know where the computer is? Using your IP address, they will know. Okay?
Got it.
Then once we created VPC, DHCP, and ACL, security group, will be automatically created.
What is the HCP?
See, these are the internal functionalities, internal operations inside a VPC. As soon as you create a VPC, DHCP, NACL, and security group will be automatically created. As soon I'll let you know everything in detail. But these are the 3 options. As soon as you create a VPC, they will be created automatically in your VPC account. Okay?
Okay.
Then a VPC is confined to an AWS free zone and does not extend between regions. So try to understand that when you create a VPC, okay, it belongs to only one region. Say I'm using Mumbai region, okay, and you are using USA region. So VPC under this region and VPC under this region. Okay, they can't connect each other with each other. Okay,
They cannot connect to each other.
see, they can send data, they can receive data. No issue with that. If we move with public subnet, they can connect with each other in sending and receiving part. But if you want that in Mumbai region, you are creating a VPC, and same VPC you want to create in another region, and these two regions should be combined, right? Extended, right? That cannot be possible. This region can have VPC different. This region have different VPC. Means in this is inside the Mumbai region. This is inside the USA region. Okay, let me explain it to you by a good diagram. Just if you understand this diagram, your VPC concepts are very much clear. You don't need to understand anything else. So say this is your AWS wall. Okay, AWS cloud wall, the outer wall. Okay, and you are in the region. This is your region. Getting it?
Uh-huh.
This is your complete region, you can say. Okay, this part, the outer box is your region. Now inside this region, what we create is VPC. So this box belongs to VPC. Getting it?
Uh-huh. Yes.
This is complete your VPC. Let me just draw the line with this there. So this is complete VPC you have. Okay, this is your complete VPC. Now inside this VPC, you have two availability zones. Okay, say this is your availability zone A, and this is your availability zone B. Okay, now
Uh-huh.
inside these availability zone, you have created two accounts. Okay, so first you have created one account of this instance, and you have applied a NAT gateway here. Okay, and this NAT gateway is connected to a router, right? This is a router, and this is now giving the information to AWS cloud, that is internet gateway.
Internet gateway.
Okay, and
Mm-hmm.
router is also connected with the another region, sorry, another availability zone EC2 instance, and this is also connected with this one also. Both of these are connected to this EC2 instance, right?
Okay.
So because here we have a NAT gateway, this is known as public subnet,
Uh-huh.
and say the value will be CID will be 10.0.00/24, and this is because no NAT gateway is here, so we can't able to connect with the internet. So this is known as private subnet.
And they don't have a public IP.
Okay, and this is 10.0.1.0/24.
Right?
This VPC is 10.0.00/16. Okay, getting it?
Yep.
Is it clear?
Uh-huh.
This is the complete diagram, or you can say complete architecture of VPC. Now, the main important term comes in is routing table. So this is the routing table of this public instance. So they will, in the routing table, what we show, destination and target. Okay. So in destination, we have 10.0.0, the destination of VPC, and because it is local, one is will be local and another will be from anywhere you can access. That will be internet gateway. And for this, if you want to create the routing table, okay, so destination and target will be, so destination is the VPC address 0.0.0, and the target will be local, and it will be not be able to connect with the internet gateway because no NAT gateway is available in the private subnet. So what happened? First of all, if you want to create your VPC or inside your EC2, you need to go inside the AWS cloud. Okay, in AWS cloud, for a particular region, say I am creating it for Mumbai region. Okay, for Mumbai region, we have created a VPC. This is the VPC that we have created for Mumbai region. In this, we have created two availability zones. These are the two availability zones. And in these availability zones, what we have done, we have created these two data centers or these two servers. Okay, and they are connected using this router. Means this can communicate with this server, and this server can also communicate with the internet gateway. Getting it?
Got it.
Now, once the VPC is created, you cannot change its CIDR block range. Now this term must be new to you. So this is no CIDR block range is that VPC address that we have given. See this 10.0.0. This is a network of 16 bits network. Means it belongs to class B. So this you can't change once you have created an IP VPC. So what happens? See, you must have familiar with the IP address concepts. So in this, what happens? We are creating a subnet of 16. Subnet of 16 means these 2 bytes will denote the network ID and these 2 bits will denote the host ID. Okay. So once you have selected that you want 2 bits for network ID and 2 bits for host ID, you can't change it. Okay, the block range you can't change it, but before only you can select that. Okay, I want 10.0.0.0, 3 bits I want for network ID and 1 bit I want for host ID. So it will be 24 instead of 16. You can select it only once when you are creating it. Based on this, your availability zones will get the networks. So you can see here, they are given the networks as availability zone here as 10 point. This address is given here. Similar address is given, right? But inside this you can change it. Here earlier it was 16, right? But when you are creating the availability zone, you can change the subnetting part. But once this is created, you can't change it. Okay? But this IP address 10.0.10 and 10.000.1. Okay, this will remain same. These are the IP for these availability zones. And this is the complete IP address for the VPC network. Getting it?
Got it.
So this is VPC address is known as CIDR block range. If you need a different CIDR size, create a new VPC. Getting it?
Yep.
The different subnets within a VPC cannot overlap. So what the subnet means? See, this is a network. Okay, this is your. Let me explain you what is subnet. Okay, so this is a network. Say your own network. Okay, you have a server here and you want to run a process. This is a Google network. Okay, and you want some process is going on. So if you want to access the Google network, what things you need to know? First of all, you need to know in which network it is in. Then after network, you need to know on which host it is working on. Then after this host, you want to know which process is going on. Then you are able to access the Google network. So you usually say, if I know this www.google.com, I can access the Google. No. Between you and this address, there is a DNS server which is working on, this is known as domain network server. You will go to this, okay, they will send you the IP address of Google. Okay, then this IP address will tell you the network, host, and the process. Okay, now say this is only one system, but in multiple organizations, what happens? We divide the network. Say this department, this network belongs to administration department, and this department, this block is for HR department. Okay, no two can be able to connect. So what we have divided our network. So this when we divide a network, it is known as subnetting. Getting it?
Got it.
If you want to access anything in this admin, first what you have to do, you have to go to this network, you need to know. Then you have to know in which subnet ID you need to know here now. Earlier there was no subnet, so we don't need any subnet because there is only one network. Now you need to know the subnet, then they will tell you about the host, and then you will reach with the process. Getting it? So this is not netting when we divide it into two parts. So in this we have divided in two parts. See, our VPC is divided into two parts: availability zone 1, availability zone 2. This is private subnet, right? IP is same, but we have divided it into two parts. One is 00 and another is 10. These are the two subnets. Getting it? So what they are saying, the different subnets within a VPC cannot overlap. Means these two cannot be same. If they are same, they will become a one network instead of two. Getting it? This needs.
Okay, so they cannot be the same.
You can, however, expand your VPC CIDR by adding new or extra IP addresses, ranges, except government cloud and AWS China. So what they're trying to say, you can however extend your VPC CIDR. See, you have already selected it as 16, but you can increase it to 24. Okay, by adding new or extra IP addresses range you can add. Okay, but you can't do it in these regions, GOV cloud region and AWS China region. These are not possible. Getting it?
Let me see.
Means the range I told you now.
Oh, okay. Yeah, except government cloud and AWS China.
Okay, in these two regions you can't extend the range, but else than that you can extend.
Got it.
Now, the components of VPC. You are understanding the theoretical part of VPC?
Yep.
Yeah. So, what are the components of VPC? CIDR and IP address, subnets, implied routers, and their routing tables, internet gateway, security group, network, ACIs, network ACIs. Then we have virtual private gateway, then we have peering connections, and then we have elastic IP. So these are the different parts, you can say, of VPC components. Okay, in VPC you will find this CIDR and IP address subnet. You have already seen this part today. We are talked about lot about IP address and what is CIDR range, right?
Okay.
Then you will see implied router and router table. You have seen internet gateway. You have already seen security group. You already know. These three parts are left. You never means I have not discussed it yet. And as soon as we move forward, we will discuss these part also. Getting it?
Okay, perfect.
So now the another part that is very much important when we talk about VPC, that is types of VPC. How many types of VPCs we are having? So let's start with that. Okay, so we have two types of VPCs. One is default VPC and another is custom VPC. So when we talk about default VPC, it is created in each AWS region when an AWS account is created. Okay.
What happened if I delete my default VPC by accident?
So you will see what happens. Sometimes it is some services are automatically given you by AWS account. Default means either you can select it as yes, automatically it is always selected. Means automatically you will get this VPC. But default means that these are selected by them. But what they say, you can change it. So if you don't want this default VPC, you can easily remove it. Okay?
Okay.
So there will be no issue in removing it.
Okay.
They have selected some things for you, but if you don't like it, you can say, no, I don't require it. Please remove it. Write it?
Got it.
Yeah. Then it has default So it has default CIDR security group, NACL, and routing table settings. Okay, it has all these features automatically within it. Okay, and one
Okay.
default thing you will find here has an internet gateway by default. Okay, by default you will find an internet gateway inside a default VPC. Getting it?
Yep.
Another thing comes is custom VPC, how it is different from default VPC now. So custom VPC is a VPC on AWS account owner creates it. Okay, it is not automatically created. You have to go and create your own VPC, right? Then AWS user creating the custom VPC can decode the CIDR. Now, the first difference comes. The first difference we have seen that it is already created, and here you have to create. Owner will create it. The another difference you will see in this that you already got a default CIDR. Okay, range you have already been given. You can't change it, but here you can change the CIDR range. Getting it?
Okay. The CIDR is the number 16, the 24.
Yeah, that is
That's the,
the range. You can select from which range to which range you want the IP address, and you have to do the subnetting.
okay.
Then has its default security group, network, ACL, and route table. See, it also has the same default settings that you will get in the default one. Nothing will change, but you can change it according to your needs. Okay. Then the last feature that they has does not have an internet connection, internet gateway connection by default. One needs to create it if needed. Okay, here they already have created an internet gateway for you, but here if you wanted you have to create your own internet gateway.
Okay,
Okay,
great.
the differences between the default VPC and custom VPC is clear.
Yeah.
Now see what is the process of VPC, like how we create a VPC and what things we require when we deal with the concept of VPC. So have you ever created a VPC by your own?
Uh-huh. Yeah, I had created like a VPC with subnets and including the CIDR, some instances, connecting the private instances to the internet by using NAT gateway. Yeah, all that.
So what when you create a VPC, what steps you follow?
What steps? I have to be in the console in order to tell you, okay, this is the step.
Okay.
Just create like the VPC. I just click and create.
I'll give you the steps. Okay. Just try to remember them.
Uh-huh.
Okay. So first of all, you have to say, I want to create a VPC. There will be option of create VPC. Second, you have to create a subnet. After creating the subnet, you have to create an internet gateway. After creating the internet gateway, they will give you you have to create a route tables. So in this way, a complete VPC will be ready for you. This is the flow.
Mm,
Okay?
okay.
You are familiar?
Yep.
Great. So now we have two types of subnets in context to VPC. Okay? So I'll compare it for you. One is public subnet. Okay. Another is private subnet. You have heard about these two?
Yep.
Yeah. So what in this we do? The another is private subnet. So if you will create these two subnets, okay, you will see a huge difference in the working of them, how they work. Okay. So see in the diagram I have told you the two subnets we have created. Okay. This was the public subnet, right? We have talked about, and it has a NAT gateway, means it can connect with the internet gateway. And another that we have created is private subnet, and it is not able to connect with the internet gateway. This difference is clear.
Yep.
So if we give you, I'll give you a perfect definition of public and subnet. Okay. If a subnet traffic is related to an internet gateway, the subnet is known as a public subnet. Getting it?
Yep.
If you want your instance in a public subnet to communicate with the internet over IPv4, it must have a public IPv4 address or an elastic IP address. So what I'm trying to say, okay, if you want your instance in a public subnet to communicate with the internet over this network, IPv4 means IP address of version 4. So it must have a public IPv4 address or an elastic IP address. Without these two things, without either of these things, you can't connect with the public subnet. Getting it?
Got it.
Sorry. In private subnet, if a subnet traffic is routed to an internet gateway, sorry, so if a subnet does not have route to the internet gateway, the subnet is called private subnet, right? They don't have
Uh-huh.
route to the internet gateway, that's why they are known as private subnet.
Private subnet. Okay.
When you create a VPC, you need to specify an IPv4 CIDR block for the VPC. The sorry, don't take these things in this. So this private is clear and this public is
Yeah,
clear.
the private, they don't have a public IP address because I mean
Yeah.
sorry, I'm thinking about the instances, but okay. But in the private subnet, yeah, I understand that they don't have a route to the internet gateway. So that's why it's called a private subnet. And if I create an instance and put it in the private subnet, they will not have an IP, a public IP.
Okay. Everything is clear then? Then
Yep.
some major notes you need to take about VPC. So what you can do, see, when you create your VPC, so first thing you need to allow that is the address of the VPC. And that address of VPC, we call it as CIDR block. This part is clear. The first step is this one, by creating the VPC.
Yep.
Okay. So when we specify CIDR block, it is in IPv4. IPv4 means IP address of version 4. Right now it is working it because it takes 32 bits. Okay.
Okay.
So the block size, like the address block size, they allow is between 16 to /28 networks. Getting it?
Yep.
Either you can have a 16 or either you can have 28 of blocks. You means if you are saying that you have an IP address 10.0.0.0, so you can say this is the range of IP address. Each IP address, because it is 32 bits, right? Inside this 8, 8 and 8 and 8 comes. Okay, this is known as octants. Okay, now inside this, what happens? 10, 0, 0 and 0 comes in. This is the way IP addresses are formed. Now, what happens if you select these two, 8 plus 8, 16. So this 16 becomes your first block. Means either you can select it for 16, right? And if you include this another block too, it becomes 24, right? But here only half of the IP addresses you can take. So only 28 you can take. Otherwise, complete ones are 32. After 32, only 28 blocks you can create. This you can't include inside the block. So your range starts from this to this.
Okay. When I select the for
Sorry.
the 24, for the 24.
From 16 to 20.
Okay.
So 60 after this, 16 will start. 16 to 24 is the range of blocks you can select. 16 to 28. Sorry, not 24. 28. You can select this from here. 16 is starting and till 28. This is 28 last one. You can select the block only from this for the CIDR block. No other address, IP address you can access.
Got it.
This is clear?
The address that I cannot select is for administration purposes.
These are,
AWS.
these are used for other purposes, but when we say that for VPC, I want to create a CIDR block. So the range specified is from 16 to 28 you can select. From these IP addresses you can create a CIDR block, but you can't create a CIDR block using these IP addresses.
Okay, so how many IP address I can create if I select 16?
See,
the IDR block.
See, what happens? 10.0 is now fixed. After this, if you say you want to create for only 16, so 2 raised to power 8 you can select. That is equals to 2 raised to power 7, 255 IP addresses you can create. Sorry, 254 IP addresses you can create plus 254 and 120, I think so, 127 more for this four addresses. So I think so. You can create 5, 6, 7, 8, 381 IP addresses.
Wait. So let me see. So if I select the 24 CIDR block, I said it right?
What you can do, see how you calculate the IP addresses. Actually, this is completely different concept, but if you try to understand, this, these are the 888 blocks. Okay, till here you can't select anything. After this, you can't select anything. This is blocked. You can't select. Only the specified region you got is are these 8 blocks.
In each block, they have like 255, 255
No. They
IPR.
here they have 2 raised to power 8 combinations. Here they have 2 raised to power 8 combinations. Here they have 2 raised to power 8 combinations. Here they have 2 raised to power 8 combinations. So total they have 2 raised to power 32 IP addresses in the whole world. Okay.
Wait, but what I mean, because I see when I was looking at the internet, like 255 that, 255 that, 255 that, 255, and I thought that, you know, like if I am in the, how do you call, if I select 24, how do you call 24? And CIDR block
From
is the
16.
24.
See from 16.
How do you call 16 CIDR block?
This is 8. If you add 8 means this block contains of 16.
16 what?
16 bits means you have to raise to power 16 addresses inside this. See what happens when we talk about IP addresses, they are divided into 4 octants. One octant contains 8 bits, another contains 8 bits, another contains 8 bits and 8 bits. 8 bits means 1, 2, 3, 4, 5, 6, 7, 8. Like this, 1, 2, 3, 4, 5, 6, 7, 8. These are not known as single bit. Either here you can have 0 or you can have 1.
Okay, got it.
You can form 2 raised to power 8 IP addresses. Similarly, here also you can create 2 raised to power 8 IP addresses. Here you can create 2 raised to power 8 IP addresses, 2 raised to power 8 IP addresses.
So each block is composed with bits. So it's like
Yeah.
each block is 8 bits.
Yeah, for 8 bits they will provide you, and you can have 2 raised to power 8 combinations. Means 2 raised to power 8 IP addresses. So in total, because we have 32 bits with us, we can have to power 32 IP addresses.
In the context of the subnet.
See, in
Meaning,
this, if we talk, so this 2 raised to power 16 is not of our use.
yeah.
Our use is of this 8 bit and these half 4 bits, because we have to start from 16 and we have to end it till 24, right?
Okay.
These are 24, these are 24 bits, 16 to 24 you can get. So only in your range, if we talk, we only have this much blocks remaining, 8, 8, 8. So only this much block is with us. This we can't access, this we can't access, this we can't access, because 16 is starting from here, 24 is starting from here, 24 ends here, and next
Okay.
it will be 28. If you add 4 bits more, then it will be 28, and this is complete as 32. This is not in our access, only till here you can access. Just let me show you with the box.
Meaning that if I select for my VPC the system bit, then I can have a IP addresses, which is I can have like a subnets. right?
See, just try to get it clear. 10 is fixed, point 0 is fixed, right?
Uh-huh.
Zero.
Yeah, I got it.
Okay. Now the 16th bit you can change.
Uh-huh.
Many
Okay.
combinations are possible in these 8 bits. 2 raised to power 8 combinations are present, but
Okay.
one is not included. So 255 IP addresses can form here.
Okay, got it.
Plus 4 bits more because we are including 28 bits more. So 2 raised to power 4 means x, you can say 124 IP addresses can also form. Okay, so if we total them, so it is something I calculated 381, right? They will give you 381 IP addresses. Getting it?
How do you, okay, got it. It's 127. You got 127?
Sorry.
It's like, okay, so it's like two, um is equal to, okay, 255. How do you can you read it for me?
Sorry, what?
2/5, 2 to the power of 8. Can you read it for me?
Yeah, it's 2 raised to power 8. It's 2 raised to the power.
Oh, okay, so you can read it like that. Okay, so 2 to the power of 8
Yeah.
is 255 IP plus 2 to the
Yeah,
power
if
of
you
4.
say 2 raised to power 8 is equals to 2 into 2 into 2 into 2 till 8.
Yeah,
So instead of writing like this, you can just write it like this.
yeah, I know. So it's plus 2 to the power of 4 is 127.5. I calculated because I just divide 255 divided by 2, which is 127. Because if we have like 2 to the power of 8, then equals 255 IP, then 2 to the power of 4 is half of 255.
Yeah, you can understand it like this.
So, okay, got it. And okay, I understand that. So I understand the concept.
Is it clear now?
That means, my question is, by selecting um, the the block 16, 224, which is have 2 to the power of 8. 8 bits. That means that I can create 8 subnets. I am available to create 8 subnets.
See, what happens in IP addresses, we have multiple combinations. So these many combinations, 255 combinations we have,
Oh, okay, got it. Yes.
right? Like if I'll say I have
Okay.
1 bit, I have only 0 and 1. Okay, and I want to represent. How will I say represent 0 and 1 in the form of 0 and 1? Right? These are the 2 bits. So I
Oh,
have
I got it.
represented 0 and 1. Similarly, I have 2 bits, right? So we have,
Uh-huh.
I, it is 1 bit. You can say 0 or either. If you want to fill this one place, it is known as 1 bit. So you can fill either by 0 or either by 1. Only 2 combinations are possible. Clear?
Okay, I got
To
it.
fill
So each,
two
uh-huh.
2 bits, you need 2 combinations: 0 0, 0 1, 1 0, 1 1. So you require 4 combinations, means 4 IP addresses.
Uh-huh.
Similarly, if you want to fill 8 bits, right? So you require 2 raised to power 8 combinations like this.
Yes.
So that becomes the IP address. Plus, if you are adding 4 bits more to it, so it
So
will
that means
4,
that uh, uh-huh, 2 to the power of 8, that means that
12
I can have,
combinations. 2 raised to power 12 combinations you can have.
that means that I can have 255.
No, no, don't go in that calculation. Just understand with simple term that if you have 2 raised to power 8 combinations plus
Hmm.
2 raised to power 4 combination more for 4 bits,
Uh-huh.
right? Means you have 2 raised to power 12 combinations. Means you can have 2 raised to power 12 IP addresses.
Yeah, that means that I can have, as you said, 381
Yeah.
IP addresses. That's the total, like 2 to the power of 8, which I can have 255 IP addresses. That's the total, um, how do you call it? Um, that's what I can get from 2 to the power of 8. That's how many IP addresses I can get.
Yeah.
By doing the 8 combinations, the result is gonna be
From
um,
till 24
255.
you can access.
Okay, got it.
Clear?
I got it. So I mean, I have a question.
Yeah, please.
So when I get this subnet with the 24 bit,
Then you will get 24 bit. This is the question. Can you repeat the question, please?
um, when I get the 24, the I mean the 24 bit in a subnet.
No, no, you have to give it. Say 10.0. Okay. Say you want 24. You can say 255.254. This is the last
Okay.
address you will have. So this is the last IP address you will get. And if you want to start the 24th bit, then it will start from here and it will end it at here. This is the first of 24. This is the last of 24. And
Oh, okay, got it.
you want to start 16 one, then 16 starts from 1 and 16
Okay.
at 254. This is the IP addresses.
And what I can, and it's a simple question. I might know the answer, but what I can do now, like, okay, I got all these IP addresses. What I can do?
What you can do,
Yeah, yeah. It's like, okay, so I
it's
got all
like
these
a
IP addresses.
address. Okay. If somebody has your address, what they can do? They can visit you, right? Similarly, if you provide this address to your EC2 instance, so you have a particular address for EC2 instance, and using this instance, using this IP address of subnet, you can access your EC2 instance. And somebody, because it is virtual private cloud, if somebody doesn't have your address, they will not be able to access your EC2 account.
Okay, so I mean that means with with the 24 bit, I can create I can use those many like so many IP addresses,
You have
creating many instances, um, using for other purpose. I mean, it's a lot that I can do. Like with those IP addresses, I can create like more than 200 instances.
Yes, but inside a VPC,
Yeah, I know. I can, it's a
you
limit.
can add only 200 subnets. So you can only use 200 of these IP addresses. Okay? And you can create 15 VPCs. So if you create subnets in these 15 VPCs, so there will be many.
With the 16-bit.
Yeah. See what I'm trying to explain you. See, say just you have this IP address. This is for 24 you have selected. Means you have to change this bit.
Yeah.
So, for example, your first network will be this. This is known as network address.
Okay.
You can access the network using this.
Got it. And this is,
That
okay.
from your system, if you want to go to Google, you need a network ID. This is the network ID you need. Then 10.0.01 is reserved by AWS for the VPC route.
Okay.
Right? The first one you have to give it to the VPC account.
Okay, got it.
Okay. 10.0.2. Okay. Reserved in AWS the IP address of DNS server. I told you what is DNS? The server which converts your domain name to the IP address. That means you have www.google.com. DNS, you can get its IP address. So this IP will be given to that DNS server who is converting it.
Okay, got it.
Then 10.0.0.3 is reserved for future use. They are not giving it to you. It is reserved for future use. Means in future, if the requirement comes for more IP addresses, they will give it to them. And the last, I told you, 255 is broadcast address. Broadcast is of two types: limited broadcast and directed broadcast. In limited broadcast, you can only communicate with the, means you are a single server, you want to give information to multiple people in your own server. This is known as limited broadcast. But in direct broadcast, this is one server, another network. From this network, you want to send the information to multiple servers in other network. This is known as directed. So these are reserved for this. Getting it?
Okay, so there are like three IP address that AWS use.
Means the how many, see, these are fixed. What are fixed?
I know.
Network address is fixed. For VPC router is fixed. For DNS server is fixed. Other you can use for creating the in the availability zones.
So 252 is available for me. 252 addresses is available for me.
Yeah.
Just subtracting three IP addresses that I cannot use. It's only used for AWS.
If I show you the calculation, so AWS do not support broadcast in a VPC. If you're creating a VPC, they don't allow you to communicate to multiple members, but it still reserves this address. So now if we have, actually we have 65,536 IP addresses available. If you calculate all the addresses, and from that I'm subtracting 5 that are fixed, then we have 65,531, means from 256 addresses we are subtracting 5, means we will have only 251 addresses with us. So using these 251 addresses, we can create availability zones.
Oh, you're counting zeros?
Sorry?
You're counting zero. So for the IP address, for the network,
256
the route
already
table.
Because we are selecting the end bit, 24th bit. How many addresses it has? It has 256 addresses. Okay? And out of these 256 addresses, yes, I'm counting the 0th one, the 10.0.01 also. That's why I'm saying it is 256. So out of 256, only 5 are already reserved. See, these 5s are 1, 2, 3, 4, 5. They are already reserved. Remaining are 251 addresses. Right? So these are available for us to connect with multiple availability zones. Now we can use these 251 addresses to create the subnets. Now it can be either private subnet or public subnet.
But we only allowed to create 200 subnets in total.
Yeah, we are only allowed to create only 200 subnets.
Which is too much, but you know, it's good. And got it.
So inside of VPC, we can only create 200 subnets.
Inside a subnet, how many instances you can create? What is the total?
Actually, subnet means instance only. One instance will have one subnet.
What?
You are saying how many instances we create. So I'm saying you that there is the diagram. Okay. This EC2 instance has this subnet.
Okay.
This EC2 instance has this subnet.
Got it. So it's like I can have like 251 instances. Like for example, I mean I'm
IP addresses are 251, but you can only make 200. Okay, subnets.
200 were subnets. Wait, and you saying subnets and instances?
Yeah, actually subnet means you are providing a different environment. I told you no. What happens? Oh, where is the subnet part? See, this is the complete network. Inside this network, you're dividing the network. This is one subnet, now another subnet.
Okay.
So I am talking about these subnets. So you have to give this a new ID, you have to give this a new ID. So what you're doing, you are taking a VPC, complete VPC, and you can divide this into 200 parts.
So, okay, so that's what you said is the environment. So the subnet is the environment.
Sorry?
In this environment, it's like you said, like the subnet is the environment.
Yeah.
In this environment, I am...
different environment they are giving you, the different space. Say,
and I am...
in this
and I
complete
am...
VPC,
okay.
you have 200 different subnets.
Yeah, I got it. Okay, let me explain. So if I understand. So this is the environment, the subnet. And in this environment, I am able to use 251 IP addresses.
Yeah, inside.
Inside the environment. So it's like the condition. The subnet is the condition, the environment. I use 24 bits. Then I am able to manage
See, it once
whatever I
here.
want to.
VPC, you have 251 addresses.
Yeah, I understand
You
now.
can divide it into 200 parts. So say one IP address you're giving to this, second IP address you're giving to this, third IP address you're giving to this. To every subnet, this is subnet 1, subnet 2, subnet 3, right? Like this subnet goes on till 200 and you are assigning them the subnet IP address. Getting it?
Got it.
Everything making you sense?
Yes, I have another question.
Yeah.
I can create a subnet 1 using 24-bit. Let's say 10.0. Can you help me? Okay, the 0, the 1.
0, that 1. Right?
And second
This is
subnet.
already, yeah, this is a subnet. But
Okay.
you can't use this because it is already reserved.
Okay. So it's
Reserved for AWS.
so it's gonna be 6.
Yeah, 10.0.0.6.
6.
Subnet. Say sub.
Okay.
Like this.
And subnet 2 is gonna be the 7.
Yeah, see this diagram. This is 0. This is one subnet. This is in another network. This is another subnet. 1 0. Because here 0, see 0.0 is one network, 1.0 is another network.
Okay, perfect.
Clear?
And
Yeah.
in each of these subnets, I have 251 IP addresses. The environment, I am available to use 251 in subnet 1 and subnet 2. Right?
Inside this complete, you can use 251 IP addresses, right? But you are allowed only 200 to use. So 251 addresses you have. See what happens, try to understand that. You have 251 houses up with you. Okay? But out of them, only 200 are available for you to live inside them, and others are restricted, are not allowed for you to live. So you can have 200 addresses, 200 subnets with you inside a VPC. Getting it?
Got it.
Clear?
Yeah, and in each subnet, I am able to use 251 IP addresses.
Yes.
Right? I mean, I know the limit. I know the limit, but I'm good. Yeah, I understand.
Clear?
Yes.
So let's end the class. Everything is clear to you? Then tomorrow
Yeah.
meet at the same time. Okay? Still you face anything while revising, let me know. Okay?
Okay. Thank you. Have a nice day.
Have a nice day. Bye.
Bye.